sponsored by AICTE and organized by the Mechanical Engineering Department at MITE. We have with us today Mr. Ashutosh Singh, who is an EV design engineer at ISIE India. Mr. Singh is a graduate in mechanical engineering from ABES Engineering College of Dr. APJ Abdul Kalam Technical University, Lucknow, Uttar Pradesh. On behalf of the department, I cordially welcome you, sir. Mr. Singh is an expertise in design and simulation of automotive components. He has proficiency in the concept of design, product design, simulation, FEA, DFMEA, testing and validation. He has presented and published a research paper on weight optimization and roll cage design in UGC in a Springer journal. He has professional membership in bodies like ISIE, SAE, and SESI. He has also developed a patented working model on pneumatics in association with Honda cars. And he also has participated in SAE event like FE Cycle and Baja. With that, I hand over the session to Mr. Ashutosh Singh and request him to proceed with the lecture. Over to you, sir.
Yeah. Thank you, sir. Thank you for the introduction. Yeah. Am I audible, sir?
Yes, sir, you are audible. I'll just stop my
Yeah. Okay. Okay.
presentation.
Okay.
Following
So,
that, you can kindly proceed with your lecture, sir.
yeah. Okay. Okay. Sure. Okay. Thank you. Thank you. Yeah. Okay. So we will be starting with our presentation, and let me first present my screen to you. Hello. Is my screen visible to you all?
Not yet, sir. Yes, yes,
Is it visible now,
got it.
sir?
It's visible now.
Yeah. Okay. Okay. Okay, okay, okay. Okay. So we will be starting with the session of sustainable solutions in hybrid vehicle. And in this session, we will be covering EV analysis and crash test analysis. And the content that we are going to cover over here is design advancements. And then we will be seeing how import of design from SolidWorks to any other software, how to do that. And then ANSYS introduction, and then ANSYS specifications, and then the calculations that we can use to calculate the force that are going to appear on any of the design or any of the roll cage that we have designed, basically roll cage of an electric vehicle. And then we will be having a model simulation on ANSYS and then meshing parameters that we are going to use over there. And after this, we will be covering the results. So this is the majority of the points that we are going to cover in this session. So let's get started with it. So I'll be switching towards my SolidWorks window where I will be importing the design from SolidWorks to ANSYS. So let me show how to do it. So is my SolidWorks window visible to you all? So this is our SolidWorks model. Okay, let me do it. Okay, okay, okay.
No, not yet.
Visible?
Yeah. Yes.
Yeah, so this is my SolidWorks model. I have designed a roll cage considering our specification and rule book. Okay, so this is a, common roll cage that is going to be used by any of the vehicle of an ATV. So we will, if suppose we are going to design an all-terrain vehicle which is going to be a electrical. So we will be using this type of roll cage, and I have used Weldman command to manufacture and design this roll cage. So I'll be importing this roll cage into ANSYS. As you can see, SolidWorks only allows SLD files to be saved in our roll cage. So the format of the files that will be going to save is SLD and we will be converting that SLD file first into ANSYS files. ANSYS supports IGS or step format files. So just go to save as. You can find save as option on the topmost bar of the SolidWorks. Go to save as, and you will find options like, you can see SolidWorks only support SLD file. So just change it and you will find IGS or step file over there. So first of all, we will be saving is that it as an IGS file and then a step file. So both of the files can be supported by ANSYS, and then we will be importing these two files in ANSYS. So I've already saved them. So I'll be switching towards ANSYS now. Yeah. So this is our ANSYS window, ANSYS workbench. Is it visible?
Ashutosh, please proceed. It is visible.
Yeah, okay, sure, sure. Thank you, sir. Thank you for the clarification. So this is our ANSYS workbench. We can see ANSYS provides us many tools to simulate a static structure or a component. You can go through this component. You can see the analysis system will provide some of the major of the components or major of the commands that we can use to simulate any of the component. So in this session, we will be having an overview about static structure. So we have imported our designs and we have saved it in IGS and step format. So we will be using a static structure command. So just double click on it and you will find the static structure specifications occurred on a project screen. So this is how static structure will going to occur over here. Now, if we want to specify any data into it, any material that what type of material do we want to specify to our roll cage that we have designed. So we will be using engineering data over it. Just click on engineering data and click on edit. And after clicking on it, and you will be going towards the data specification table where you can define your own material. Suppose I want to include material AISI 4130, which is chromoly, as my material of the roll cage. So I'll just click AISI 4130 and click enter. And this material is now specified, but the properties are not yet specified into it. So we will be choosing some properties from the property specification table that is having some physical properties, linear elastic properties, hyperelastic and then hyperelastic, experimental and hyperelastic properties. So we will be choosing some of the major properties that can be used during analysis. So first of all, we will be specifying density. You can see density has been added over here, and then isotropic elasticity properties. So we will be getting Young's modulus, Poisson's ratio, bulk modulus, and shear modulus after adding this. And then we will be adding stress. So tensile yield stress and then tensile ultimate stress we will be using. So these are the majority of the properties that we are going to specify for the material that we are going to specify, which is AISI 4130 chromoly. So after specifying all these properties, you can use your own specified material. And I've already specified a material over here, which is structural steel. So I'll be using structural steel over as a material of my roll cage. So let's get started with this material only. So in this way, you can specify the properties. Just input the value of density over here, and then Young's modulus Poisson ratio, which is 0.29, and tensile and yield will be tensile will be 460 MPa, and ultimate will be 560 MPa for AISI 4130. So by after specifying all these units, you will be using this material as your specified material for the roll cage. So I'm currently using structural steel, so I have no need of specifying 4130. So just switch to my project window and just select the data from it, engineering data. So I'll be deleting this, and this is my material that I'm going to use. It is having all the specifications such as density, you can see 7850 kilogram per meter cube, and all the other specification: tensile yield, compressive yield, tensile ultimate, and compressive yield. So these are the specifications that we are going to use over here. You can see engineering data is clicked right. So specification of data is done over here. Now we are going to import a geometry over here. Just click on geometry. If you right click over it, you will find a dialog box where you can see different options. It is showing you a new space claim geometry. So ANSYS provide a platform which is a space claim geometry platform, in which you can develop your own model in the ANSYS itself. And if you want to import a geometry, then just go to import geometry over here and go to browse, and you will find your saved files over there. So I've already saved some file which is roll cage in IGS format, and then roll cage in step format. So I'll be using roll cage step file as a model to be imported. So our model is imported, and you can see geometry has been ticked right. Now what we are going to do, we will be specifying some of the specifications in model. What type of force do we want to apply on it? What are the meshing parameters on it? And then what are the specifications of the force that we are going to apply? Is it on the front impact, side impact, or rear impact? So for that, just right click on model and click edit. So you can see our mechanical workbench will be going to open over here. The status you can see over here is starting mechanical workbench. So ANSYS will be switching the model to the mechanical workbench, and then connecting this ANSYS workbench to the mechanical workbench. And then we will be start working on this mechanical workbench. And similarly, along with this, we will be importing the model to it also. So it will take some time. Let's wait for the mechanical workbench to get open. And after the importment of the model, we will be specifying some setup solutions and results to it. So this is the overall process that we are going to perform over here. So our mechanical workbench is open. You can see, and ANSYS is now importing the model of step format into this mechanical workbench. You can see the progress, and it is converting the CAD model to ACIST model, which is the basic supported model in ANSYS. And after this process has been completed, we will be getting ANSYS model of our ATV roll cage. So you can see we have successfully imported our model. This is the same model that we are having in SolidWorks, and this is the same model we have imported in ANSYS. So this is a step file of a model. You can see geometry has been specified over there, material has been specified, and coordination system and connections are also been specified. Coordination system and connections are basically dependent on the type of material you imported. Is there any problem, sir?
Okay. Every month ಕಟ್ತಿರಲ್ಲ ಸರ್ ನೀವು ಇದು EPF ಕಟ್ತಿದ್ದೀರಾ? EPF ಅಂತ.
Okay, sure. So this is our model geometry, and we have 4 steps to be done now. So we will be using the meshing analysis over it and creating the mesh. So for creating the mesh, just go to mesh parameters, and you can see after clicking on mesh, you will find different materials over it.
ನಿಮ್ಗೆ ಮೊನ್ನೆ ಹೇಳಿದಲ್ಲ.
So there's a bit disturbance.
Yeah, it is sorted out, sir. It's sorted
Okay.
out. Very sorry. Please continue.
Okay, no problem. So for inserting mesh parameters to it, let me define you first about the meshing parameters. So the model that we have imported from SolidWorks, if we try to simulate that model on SolidWorks, SolidWorks basically provide you to create a 1D mesh of that model, as we are having that tubular space frame model of our roll cage. So in SolidWorks, that tubular space frame will be considered as a beam mesh. So it will form a 1D mesh of beam type. And as compared to SolidWorks, ANSYS allows you to create 1D or 2D type mesh. So this, if we perform meshing over here, we will be getting a 2D mesh of quadrilateral and triangular type. Let me show you how meshing has been performed. If you click on mesh, you will see many of the specifications such as sizing, quality, inflation, advanced and statics. So we will be performing meshing over there, and then we will be having an overview of it. Okay, so just mesh, and meshing has been started. So it will be meshing all the particular components, all the particular beam that are included in the roll cage. So as soon as meshing has been going on, let's have an overview of the calculation.
Sir, may I interrupt you?
Yes, sir. Yes, sir.
I think there is a problem with the video feed. I'm not so sure, but
Okay, okay, okay.
anyone in the audience, are you able to get the video feed?
Let me check, sir. Let me check. If there is any problem, I will sort it out.
Because I am not getting. Yeah, okay.
I think the video is
Sure,
bit
sir.
stuck.
Because I'm not able to get the video feed right now.
Let me check. Let me check.
Oh, it's okay. Sure, sir.
Yeah, yeah, sure, sure, sure. Yeah, I'm. Yeah, okay, okay, okay. Hello, sir. Is my window
Yes, sir.
visible to you?
Yes, sir. Yes, sir. It is.
Is it okay, sir? Now?
Yes, sir. It's fine.
Okay, 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 okay. So you can see meshing process is being going on over here. So it will take some time to get the roll cage meshed. In that time, we will be having an overview how calculations are going to be performed for the force analysis. So we will be switching towards calculation part now. Let me switch my calculation window. Yeah, is my window visible to all? My calculation window?
Yes, sir.
Yeah, okay, okay. So we will be proceeding with the calculations. So
Yes, yes.
regarding the calculation that we are doing, okay, okay. So regarding calculation that we are going to have for simulating the roll cage, we are going to use some of the majority specifications. So for suppose we have designed a roll cage of having a weight of 30 kg. Okay, so this is the weight of our roll cage, let's suppose, and the overall weight we are letting is overall weight will be, let's suppose it should be around 250 kgs. Okay, so this will be the overall weight. Now what we are going to do, we will be specifying some of the specifications over here. Let's suppose the velocity of the roll cage will be 50 kilometer per hour, which is going to be 13.88 meter per second. And then let the impact time or time of crashing will be around 0.2 to 0.3 seconds. So this impact time will be given by NHTSA data. NHTSA is National Authority of Testing and Specialization of Analysis of the Vehicles. So according to NHTSA, if any of the crash tests will going to happen in any of the vehicle, then the impact time of that crashing will be around 0.2 to 0.3 seconds. So this is the specified value from NHTSA. So now what we are going to do, we will be having the calculations. So for calculation, we will be using impulse momentum theorem. So let's have a look over it. Let me clear it all. So for impulse, we will be using impulse momentum theorem. So from impulse momentum theorem, which is force into time is equals to mass into velocity. You can find this impulse momentum theorem in any of the research paper. I have also written a research paper of weight optimization and force analysis of an ATV roll cage, which also specified this theorem, and it got published in Springer publications. So according to the impulse momentum theorem, we will be calculating the force from it by using mass and velocity and time. So for front impact analysis, in which the vehicle is going to be crashed from the front side, so we will be using front impact analysis over here. So for this, the force will be mass, we have specified the mass as 250 kgs, and the velocity is 13.88 meter per second, and the time will be 0.2 seconds. Let's suppose we will be taking the point as 0.2 seconds. So we can take any of the time up from 0.2 to 0.3 seconds. So this will be 250 into 113.88 divide by 0.2, which is 17,350 Newton. So this is the amount of force, which is 17,350 Newton is the amount of force which is going to be developed in the front side if our vehicle running at a velocity of 50 meter per second got crashed in a wall which is static. So this is the specification that we have to take. Now moving ahead, so we have got the force in front impact, which is 17,350 Newton. So this is the force that we are going to apply in front impact analysis. Now moving ahead with side impact analysis. So for side impact, we just have to double the impact time, as I'll show you. Our vehicle is going in this direction, let's suppose, and for the side impact will occur if any of the vehicle will have a crash from this direction. So the impact time as compared to the front impact, in which the wall is stationary and the vehicle will be crashing into this. So this phenomena is having less impact time as compared to this phenomena. So we will be assuming that our impact time will be doubled by 0.4 second in side impact analysis. So according to that, our force that is going to appear in side impact analysis will be half. So 17,350 divided by 2, we will be getting the force we are going to apply in side impact analysis. So this is how we are going to calculate all the specifications of front and side impact analysis. So the force will be 8635 Newton. So we are having the forces of front and side impact. Let's overall conclude it. So for front impact, which is having, we are having a force of 17,350 Newton. So let get an approximate value of 17,500 Newton. We will be applying this force. And for side impact, we will be having a force of 8,675 Newton, or we can approximate it to 8,680 Newton, whatever we want. So we will be applying these two values of force on front and side impact. Similarly, for torsional impact and rollover impact. So these are the two major simulation conditions that we have to apply on our roll cage. So for torsional impact, we will be using hit and trial method. We will be applying a force of 3G, 4G, and then 5G. So how to calculate the G force? Let me show you. So G force is force, that is mass into velocity over the impact time into the factor of the force. That is, if we are going to use a 3G force, so we'll be applying the specified force that we have calculated in front impacted into 3. So this is how we are going to calculate 3G force. So we will be using 3G, 4G, and 5G forces for hit and trial method in torsional and in rollover impact. So after applying all these forces on various nodes and various specified areas that I'm going to show in ANSYS, we will be getting the factor of safety and stress values. Now we will be having all the specified forces for front impact, side impact, torsional impact, and rollover impact, and then also for rear impact. So for rear impact, it will be going to same as for front impact. So we will be specifying all the values on our model, and then let's see how our model will be going to behave. So let's get started with our simulation. Let's see if meshing has been completed. You can see, let me switch to my meshing window. You can see meshing has been completed. Is it visible to all?
Yes, it's visible, sir.
Okay. So our meshing has been completed. I've already told you I've used a 2D mesh. So I'll be explaining about meshing first. You can, if you zoom it out, you can find a structure of triangles and quadrilaterals in my meshing model. So a 2D mesh will only specify two types of patterns, that is triangular type and quadrilateral type. So this is how a meshed roll cage will look like. So why do we perform meshing is, so meshing will divide the particular component in which we have applied the mesh into small number of units or small number of pieces, so that any of the stress analysis, any of the stress that is going to appear on that, we can uh, easily verify that and easily view that. So this is how we will be performing the meshing in ANSYS. So after specifying the mesh parameters, we will be specifying the force that we have calculated yet. So for front impact, we will be using 17,500 Newton. And then for side impact, we will be using 8,780 Newtons. So just go to static structure, and if you go there, you will right click on it and you will find insert option over here. So just go to fix support. So before performing any of the simulation, what are the things we have to take care of? For example, if we are performing a simulation in ANSYS or any of the software, we have to define some of the fixed points, that is constraints that are going to be in contact of the ground or in any of the form that are going to be a fixed point. And then we will be also specifying a point where force is going to exert. So first of all, we will be specifying the fixed point in terms of front impact analysis. So we will be specifying the knuckle point over there. So just go click on fix support and choose any of the point that is going to be fixed. I'll be choosing a node. You can see, you can select any of the vertex, any of the face or edge to be a fixed point. So what I'm doing is I'll be choosing a node over here. Let's see. So this will be my fixed point. first fixed point, and then the second fixed point will be from the rear side, first, second, and then two from this side. So these are the 2 points where my suspension geometry will be going to attached here, and this suspension geometry will be directly attached to the tires, and tires are in contact of the ground. So that's why I'm fixing these 4 points as my fixed points. So I'm just click on apply. So you can see fixed support has been applied over it. Now what we are going to do, we will be having a force over it. So we'll be applying force. Just click on static structure and go to insert and go to force. So we will be inserting the value of force over here. So if you consider the model, you can see the force will be going to appear in negative z-axis. This is the positive z-axis, and we are applying force in this direction. So force will be in a negative z-axis. So just go to vector and change it into components. First select the geometry on which you want to apply force. So in terms of force, the front impact analysis, the front bulkhead will be in stress. So we'll be applying these 4 points. Let's select these front 4 points as our impact analysis points for the front impact. So click on apply. You can see force has been applied on this, but there is no value or no components over here. So just specify the value, and we have already discussed that the force is going to be applied in negative z direction. Just click on negative z and apply the force. It is 17,500 Newton. So click OK. If you specify 7,500 Newton, then you can see the direction of force will be in positive z direction. So we will be specifying the force in negative z direction. Just, yeah, this is how you apply the force in negative z direction. So we have specified our force over here, and each and every component will be under the load of 7,500 Newton divided by 4, as we have selected 4 nodes. So this is how you will specify the force and fixed support over here. So this is the force that we have applied. Now we are going to have some results over here. Just go to solutions and choose what type of result do we want in the analysis. So we want to have deformation, which is total deformation with us, and we will be having a strain, which is going to be a equivalent or 1 Mises strain, and then we will be having stress, and after this we will be having a factor of safety. So just go to this tools option and go to stress tools, and you will be specifying the factor of safety over here. So these are the 4 major parameters that we are going to include in our analysis study. So after specifying all the parameters and all, after specifying all the commands, just go to solution and go to solve. Now our study is being solved. So this is how the roll cage analysis is going to start. Now it will first verify the meshing has been correctly done or not. You can see we have already specified the mesh, but it will check the meshing over there, and then it will start the study of ANSYS. So it will be starting the ANSYS study. So meshing has been completed. Now it will be performing the simulation over there. You can see the overall progress over here. So it will take some time to simulate the roll cage. Until then, we will be switching towards SolidWorks, and we will see how to design and develop a model in SolidWorks. Then we will be analyzing the results, how ANSYS will going to give us the result for front impact analysis, and similarly we will be having the overall results of front side and rollover, torsional, and side impact analysis. So we will be switching now for SolidWorks to see how we can develop and design a model in it. So I will be switching towards my SolidWorks window. So I'll just open my SolidWorks, and then we can have an overview of how to design any of the component in SolidWorks. So let's switch towards it. The SolidWorks is loading. Let me give a minute before loading it. Just a second, sir. I'll be switching to my window of SolidWorks. Just a second. Okay, 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 okay.
Sure, sir. No issue. I would like to also say that you are just come out of
Yes,
the
yeah.
presentation mode, sir.
I'll just switching my window. So I'll have to come out from my presentation window. As I'm
Sure,
using two software at a time, that's why it will taking time.
fine.
So just a second. Yeah,
Sure,
okay,
no
okay.
problem.
Thank you. Yeah, is my screen is visible?
No, sir. I think you need to go 1 minute. Yeah,
Okay,
it is.
okay,
It
okay.
is.
So this is my SolidWorks window, and we will be having an overview how we can design and develop a roll cage or any of the electric vehicle roll cage over here, and we will be also try to simulate it over here as we have done in ANSYS. So let's get started with in SolidWorks. So this is our developed roll cage model, the same model that we are going to use in ANSYS. Let me open it. Yeah, so this is my model that I'm having with me, the SolidWorks model of the same roll cage that we have used in ANSYS for simulations. So we have developed this model and now we are going to directly simulate it over here with the same force value that we have just calculated. So for simulating a roll cage in SolidWorks, you just have to go to simulation command and go to new study over here, and you will be specifying what type of study do we want. Is it a static study? Is it going to be study with you by using frequency, a topology, design, a thermal study which consider temperature, buckling, fatigue, non-linear, linear, and then some modeling. And we are also having some drop test and pressure vessel design studies for different components. So we will be having our static simulation over here on the roll cage. So we'll be naming it as front impact analysis. So we will be using our front impact analysis study over here. So I have just renamed it at front impact analysis. So it will be switching towards the simulation window, and it will be calculating the number of joints the total number of joints that we have acquired in designing and developing this model of roll cage. So it will be showing you all the particular joints that we are having over here. You can see if yeah, this is the visualization of number of joints that we are going to use. So these are the total number of joints that we have in our roll cage. So we will be first specifying the fixture. As far as simulation in ANSYS and SolidWorks is considered, some things are similar. So fixture are going to be the same as we have applied the fixed geometry in ANSYS. We will be going to apply the fixed geometry in SolidWorks. So considering the fixture, what type of fixture do we want over here? So we will be using fixed geometry and the joints. So we will be fixing some points over here. Just click on the point that you want to fix and it will occur over here. So I'm taking 4 points similarly that I have taken in ANSYS. So I'm taking these 4 points in SolidWorks as well. So clicking OK. So these 4 points, I've already used these 4 points for ANSYS, and these similar 4 points I've used in SolidWorks. So I have specified fixed points for my roll cage. So external load, as we have applied the load in ANSYS, we will be applying similar load in SolidWorks. So external load, we will be using force over here. So a force of 17,500 Newton. What type of force do we want? If we want to apply force on vertices and points, then we can select this. Or for joint, we can select this. And for the beam, we can select this. So we will be using joints. Let's see. So on this joint, and similarly, these are the four joints of the front bulkhead we want to apply force on, and we'll be choosing a reference plane over it so that if we can specify the direction. So for reference plane, you have to move towards your roll cage designing history or the type of plane that you have used to design it. So you can see if we specify our top plane, we will be not be using the force in this required direction. So we will be choosing front plane over it. So we have specified the plane, and you can see how what we are doing up after specifying the plane. So after specifying the front plane, you can just go to the direction in which you want to apply force. You can see after specifying the front plane, the force direction will going to appear over here. So this is the force direction now currently. So we will be reversing the direction. Just click on reverse direction, and the direction will be reversed, and we'll be applying the force according to our requirements then. So model is getting loaded up. So after then we will be specifying the direction for it. So just wait for some time. Yeah, so we'll be applying the force, just reverse direction, and then clicking on the value. So we will be specifying the value to it. You can see all the specified members on which we are going to apply force. So these are the four nodes that we have selected, and this is the front impact. This is the front plane we have chosen for specifying our force value. Now you can see all the beams that are going to be considered in the force. So after considering all the beams, you can see we can apply the force value to it, and then click right, and then we will be having our solution results. So we will be applying the force first, which is 17,500 Newton. So click OK over it. Yeah, so you can see force per item will be 17,500 Newton. So this will specify that the per node will be having under a load of 17,500 Newton, which is not the requirement of us. So we will be applying a force of 17,500 Newton in all four nodes. So just click on this and click on edit definition, and you can just divide it by force to require to specify the requirement that we want. Yeah, so this is the required force. So we'll be applying a total force of 4,375 Newton per node. Now, moving towards meshing, the same phenomena that we have performed in ANSYS. This is the same phenomena. Just go to mesh, and or you can click on run study. So it will automatically create mesh and then solve the study for you. But we will be specifying the mesh. So just go to create mesh option, and it will creating a mesh for you. So if there is any problem in the roll cage, then no mesh will be formed, and if the roll cage is okay, then meshing will be completed. So as you can see, beam mesh is being performed and mm, formed over here. I have already told you the difference between meshing in ANSYS and meshing in SolidWorks, as it is a tubular cross section. So the type of mesh that we are going to have over in SolidWorks is beam mesh. So this is how you are going to define the meshing parameters over there. Or you can, if you want, you can just refine the mesh size. I'll show you how to do it. For refining the mesh size, just click on mesh and go to mesh advisor. You can see all the specified values of meshing over here. if we show you the mesh advisor, there will be no interference in your model, so our model will be okay. So this is the first clarification of troubleshooting your roll cage. If you are having any of the interferences in a roll cage, then meshing will not be completed. So you can see study is okay, bodies and material is okay, interaction will be okay, and then we are going to have a process of mesh and run, and then we will be having results. So you can see no interaction is there. Just go to simplify model, and if we want to see the specifications of meshing, so this is how you can identify any troubleshooting problem which is going to be appear on here. So just click on run this study, and you will be getting the mesh. Yeah, so I have already clicked on run the study, and I'll be just waiting for the results to be included in it. So let's see if is there any problem, and then we can also troubleshoot it. So you can see it is processing real constraint and e groups in meshing, and it is solving our model first. Then we'll be having some results. You can see for front impact analysis, it is solving our model. So, and we are having results over here. You can see SolidWorks has generated some mesh results. Let me show you those results. Just shrink it a bit. Yeah. So we'll be having some results over here. Let's see the stress first. Click on show, and you will be having the stress value. I'll just hide this up. So this is the specified results that we are going to have in ANSYS and in SolidWorks. So you can see the total number of stress, the maximum value of stress that we are going to have in SolidWorks is 2.358 Newton per mm square, Newton per meter square, and the yield stress of this material, we are having a material of AISI 4130 in this SolidWorks, and the yield stress that we are having of this material is 4.6. So the factor of safety, we can see factor of safety over here. Just include factor of safety. Yeah, so we'll be including factor of safety. You can see we will be getting a factor of safety of 2 in front impact analysis. So our roll cage is quite safe, and we can use it in designing and development of our vehicle. Okay, so this is how you perform the front impact analysis. Let's see some more results over here. So let me show you. So this is an automatically generated model. Let me clear it for you and show you the true scale model of it. Let me just correct it. So this is the model. Go to charting options. You can also specify the maximum and minimum annotations, or you can also specify the points, or you can see the points where you will be getting the maximum minimum stress. Just click on show maximum minimum annotations, and you will be getting the maximum minimum values. Just go to definition and use the true scale and click OK. So this is the true scale model. So in actual, what is the deformation that we're going to have? So let me zoom it for you and show you the point where we'll be getting the maximum and minimum value. So the maximum stress that we are going to have is on the knuckle point, which is 2.35, which is way less than our yield stress. So we are having a factor of safety of 2, which means it will be able to bear a load of twice the value that we have applied on it. So this is how we can identify and generate the results in SolidWorks. Let me show you the displacement. So this is the displacement results. Let me correct it with by using edit definition and changing it to true scale value. So this is the automatic generated result. Just go to true scale. Yeah, so the maximum deformation that we are going to have in our roll cage is 3.6 mm. So let me show you the maximum and minimum value of these results. So maximum and minimum values, click OK. And the maximum deformation that we are going to have is over here. In this point, we will be having the maximum value, which is 3.62. The total deformation, and the minimum value is 1 mm. So this is how you evaluate your results, and this is the factor of safety. Let me show you once again. So 2 is the minimum factor of safety that we are getting. Now, after having the results of front impact analysis, let's see the results of side impact analysis. So we will be having a new study over here. Just click on new, and we will be moving towards the side impact analysis study. Just type here side impact. Yeah. So we will be moving towards side impact study now, and we will be specifying the field that we have calculated on in sideways. Just load it, and it will be calculating the joints. So we will be having the similar procedure over here. Just we will be simulating in, and then we will be analyzing the results over there.
Sir, I have a question. Have you tested this
Yes,
in
sir. Yes, sir.
actuality?
Actually, this model we have developed in 2018 event, and we have also simulated it, and we have also machined and actually validated this model. And this is a tried and tested model, and this is the similar model that I have already presented in my research paper also. And based on this model, we are getting a force of this model is actually capable of having a force of more than 16,000 newtons in front impact analysis. So I have just extended the load over here. So this is a tried and tested model. It is a quite secure model, and we are also having results of this model in design competition of that competition. We have secured an all India rank of 8th or 9th, I think. So this is a tried and tested model, and this model is on Chromoleaf
Okay.
4130. Yeah, so this is quite secure model that I'm presenting to in front of you. So moving ahead, we will be having our side impact analysis. Yes, sir. Yes,
One
sir.
more
Yes, sir.
question.
Proceed.
Sir, the deflection you mentioned,
Yes,
3
sir.
mm
Yes, sir.
something. Does it match with your actual model when you tested it?
Actually, sir, the thing is, SolidWorks generally gives you the deflection which is not quite accurate as compared to any of the model or in actual testing. So deflection is only can be measured or viewed when the model is actually having an impact. But our vehicle is not having any severe impact over there. So we cannot actually define what type of deflection or what value of deflection do we have got over there. But as far as our value of force is considered, so according to that force value, if we are having that type of impact force from any other vehicle or any of the static object, then we are going to have this type of deflection. Yeah.
Okay. How do you test, sir, in actuality?
Uh,
I mean, what type of sensor do you put on
yeah, for
the model?
for testing, first we have done the crash test of our material, that is 4130. In lab, we have done the manual testing over there, and we are getting overall value of yield strength of I think more than 500 MPa. And the actual yield strength in having the chromoly material is having the actual yield strength of 460 MPa, but our material having comparatively less carbon content, which is around about 0.21 percent. So it is having a yield strength of 500 MPa. So we have used that type of material over there, and after that we have run this vehicle in actual conditions, in all terrain vehicle conditions, in drift conditions, and in suspension traction conditions. So by analyzing overall result, we have tested, and our vehicle is quite secure as compared to other vehicles. So this is our testing phenomena, and this is according to the standards of the event.
Okay, sir. So I wanted to just know what are the sensors
Sir,
that you will be
for
using during
testing,
testing?
we have just used some proximity sensors over there, and some deflection sensors, and then G-force sensors. In G-force sensor, what we are done this during when our vehicle is moving in any of the train, then it will be evaluating the force, what type of force is going to appear on our vehicle. So these type of sensors we have developed in house during our college time, and that type of sensor we have used in it. So basically, G-force sensors is the majority of the sensor that is going to give us the actual value of the force that is going to appear during performance of the vehicle during dynamic condition.
Okay, so 4130 material, it's a medium carbon
Yes, sir.
steel. Apart from carbon, what else does it have?
Sorry.
Apart from carbon,
Mhm.
what other elements does the steel have, sir?
Sir, 4130.
Like the chemical composition, the
4130
detail the
is
chemical
basically
composition.
chromoly. It is a alloy of chromium and molybdenum. Okay, so it is an alloy and it is having, yeah, chromium and
Okay.
chromium and molybdenum are the majority of the alloy in this component. Yeah, yeah, that's why it is called chromoly, sir.
Mhm.
Yeah. Okay, okay, okay.
Okay, sir, got
Any
it.
other doubts, sir? Okay, okay. So we will be
As of now,
proceeding
no,
with our
sir.
side impact analysis. Just click on fixture and we will be having a fixed geometry over here. So we will be using fixture in those similar 4 points that we have used in front impact analysis. So these are the 4 points that we want to fix. Two from this side and two will be from that side. Click OK and then we will be applying a force over it in sideways direction. Just click on external loads and apply force, and the force value is 8780. We will be applying that force. So the nodes that we are going to use in force analysis in front impact will be this node, that going to be the most prominent members of right side impact, and this node. So these are the two nodes that we are going to have, and with this we will be selecting these two nodes also. So total 4 nodes we are using for side impact. So this is the structure that we are going to use. Now for specifying the plane, just click on it and drop it down and choose an appropriate plane in which you can apply the side impact analysis. So front plane will be, I think, right plane. Right plane will be the one in which we can apply the force over it. So we will be selecting the right plane and we will be specifying the value of force then. So this is the similar process, selecting the right plane and specifying the value, which is 8780 divided by 4, so 2910 on a particular node. Let me see the direction of force. You can see the direction of force is not up to the specified mark. So we will be changing the direction of force by defining it into edit definition. Just choose the reverse direction option over here. Yeah, so this is how you can change the direction. Now we have defined the force direction, force value, and fixed points over here. Just click on run this study and it will perform meshing first, and then it will give you the appropriate results, how it is going to behave in side impact analysis. So meshing has been completed. It has generated a beam mesh over there, and now it is going to give us the results. You can see it is processing the real constraints and e groups over here. So the side impact analysis is solved over here. You can see the results. Let me introduce a factor of safety over here, and then we will be going to analyze the results. Let the model be loaded up, and then we can have an overview of how our vehicle roll cage will going to perform in side impact analysis. So stress and deformation are the default results that SolidWorks include. As compared to ANSYS, it will not give us the specifications of what type of result do we want in this. So it will automatically generate results according to its requirement. So this is the majority definition difference in SolidWorks and ANSYS, and apart from the meshing parameters. So factor of safety. So we will be having a factor of safety of 1.8 in side impact analysis. And according to standards of designing an ATV, So the minimum factor of safety that we are going to have is 1.4, and our factor of safety in both the conditions is 1.8. Okay, so our vehicle is quite safe in both the condition. Let me show you the stress value. Just go to edit definition, and I'll be changing it to true scale first, and then including the maximum and minimum value also. Yeah, so just so this is the stress that we are going to have. Maximum value stress is on this point, which is the RRH, rear roll hoop member. Before that member, the engine or the motor will be established, and yeah, this is how you are going to perform the front end side impact analysis. So after performing the analysis results, what we are going to do, we will be generating a report out of it. So how to generate a report in ANSYS or SolidWorks? So both the software basically give you an advantage of generating a default report. So just click on report over here, and you will be generating a report from SolidWorks and ANSYS. So let me show you how to do that. Click on report, and you will see all the specifications of what type of description do you want in the report. So such as SolidWorks give you an options of description, assumptions, model information, study units, material, loads and fixture, connectors, and then contact information, mesh information, sensor details, resultants, forces, and all the other specifications and results and conclusion, and to be included in the report. So you can choose any of the options that you want to get included in the report, and we will be having a report path to be saved. With just will be I'll just save it on my desktop, and then click OK, and a report generation is going on. So this is how you perform meshing and analysis in SolidWorks and ANSYS by using any of the roll cage that we have designed for basically EV. In terms of EV, what we consider is our major focus is on making a roll cage as light as possible, and with by considering the durability also. So this is how you are going to perform analysis in SolidWorks and ANSYS. So that's all with the session. I'll just take questions now. As soon as the report is generated, I'll show you the report. But from now, we will be taking the questions. Yeah. So any question?
Sure, sir. Anyone from the audience has any query on this? They can unmute their mic and directly ask the question to the speaker, or they can do so by typing their question in the
Yeah,
chat
okay, yeah.
box.
Anyway, can anything will work. I'll just if anyone having any doubt regarding the calculation part, analysis or meshing part, you can ask from me.
Sir, has anybody tried with composite material, making a roll cage with the composite material and
Yeah,
try out
the
the
thing is
technique?
that by using a composite material, the major constraint comes under is the cost constraint. If we use any of the composite material, there will be majority hike in the cost. Okay, so this is the major.
By how much probably?
For example, if I take one pipe of chromoly, which is of 3 meter, the standard market availability is of 3 meter pipe, and it will be having cost of around about 1500 rupees per pipe of 3 meter pipe. Okay, and as compared
Okay.
to that, the composite will be having a cost price of I think 3000 to 4000 per pipe.
Oh,
Yeah,
double,
double,
more than double.
more than double, sir. So this is the majority problem that occurs by using a composite over here. And and
Mhm.
uh, and one
And the
more.
notes what you are showing right now.
Yes, sir. Yes, sir. No.
Yeah, please continue.
Yeah, yeah, yeah. And yeah, yeah.
Please continue,
Yeah,
sir.
and one more thing, the thing is, before participating in any of the competition for student majorly, so they have a specified rule book for them. So in that rule book, it is only specified to use steel only as a material. That's why people generally focus on steel, not on composites. Yeah.
Okay, sir. There is one question from Sukanya Rajendran.
Yes, sir.
how do we determine the mesh parameters for a component?
Okay, okay. So the basic thing about meshing is only be done to divide the part or a particular component into different subparts so that the analysis can be performed easily over it. So for defining mesh parameters on any of the component, just try to reduce the element size as much as you can. Okay, so this is the majority of the thing that you have to take care of to reduce the number of to reduce the size of the component to as much as you can, but you cannot reduce up to very much extent as there is a constraint of computational cost which come into existence as reducing the mesh size or mesh parameters to very low value will increase the computational cost and it will take as much as time to solve the study. So that is the majority of the specification that you have to take care of. And with this, we have to also include mesh element over it. What type of element or what type of meshing do you want to be performed? It's up to you. If you are having a component which is a small component or which is not having so much force to be applied on it, you can perform 2D or 1D meshing. And if you are having a component which is quite severe and having a majority role in the in your component or in your calculations or in your design, then I'll suggest you to go with 2D or 3D meshing.
Hello? I think we lost the audio.
Yeah. Hello, hello. Am I audible, sir?
Yes,
Yeah, yeah,
yes,
yeah.
yes.
So, am I clear or should I repeat the answer?
No, I think she must have got your
Okay,
answer.
okay.
Basically, beyond a certain size,
Yeah, yeah.
there will not be much of a change in the value of the stress. So that is the point where you need to stop.
Yes, sir. Yes, sir. Yeah. Beyond a certain point, there will not be any majority of the change in the stress value. So we have to specify mesh parameters up to that point only. And one more thing is the computational cost criteria will also come into existence beyond decreasing the mesh parameters up to some extent. So we will have to take care of that also.
One more question, sir. Those nodes, what you had shown, they are all
Yes.
welded joints, right?
Yes, sir. Yes, sir. They are all welded joints. Basically, I have designed this roll cage in SolidWorks by using weldment command. So all the joints on which any member is welded over there is specified as a node. Is taken as a node in SolidWorks.
Okay.
Yeah.
So what were the biggest challenges in actually fabricating this roll cage?
Yeah, sir. Majority of the challenges included is basically to provide the adequate area to the driver, the clearance to the driver. As this is basically this roll cage is basically designed for one person only. Okay, so the major concern is with how driver is going to adjust in it by specifying all the rules that are going to be established by the governing authority. And one more thing is how we can make it as light as possible by reducing the cost as well. So considering all these factors, we have used AISI 4130 chromoly as our material to provide an adequate factor of safety or strength to our roll cage as compared to the mild steel material which is 1018. AISI 4130 gives us a yield strength of 460 MPa, and this 1018 will give us a yield strength of around about 300 MPa. So there is a big difference out there.
So this is for one person, the roll cage what you designed.
Yeah, this is an ATV roll cage basically. So yeah, this is an ATV roll cage, and we can also modify it according to 2 or 3%. No problem in that. But this design is basically focused for one person to be only driver can able to sit over here.
Okay. Will there be a considerable difference in the stress value when you scale it up?
Yeah, I think, yes, sir. Of course, of course. The thing is, if you if you are going to use any of the material, any of the other material, it will totally depend on the material type, what type of material that we are going to use. And if we are going to increase the force value, then also stress is going to increase. And the one more thing is, if we refine the mesh parameters also, then the stress generation will also have a relative difference over there. Basically,
So for a single person,
yes, sir.
yes,
Yeah,
please go on.
basically,
Please go on. Please
basically
go
the
on.
thing is, as fine as your meshing parameters were, the stress values and the stress result will refer accordingly to that mesh parameters.
So were the dimension of a single person given to you by the regulatory authority, or you came up with the
No,
general dimension of a person
yeah.
and then you
The
consider?
thing is, for designing any of the particular component, we have to follow some of the specifications or the rules given by the governing authority. So here we have used the HSLA 95% rule,
Okay.
which is defined by the American authority. So HSLA 95 authority rule will specify that if we are designing any of the vehicle, then it is designed according to the requirements, so that a normal 5.8 feet person will be able to fit into it very easily and comfortably.
HSLA 95, is it?
Yeah, HSLN 95 percentile rule. And similarly, there is another rule is in existence there, which is HSLA 60 percentile rule. So 95 percentile male rule we have used followed over here. HSLN 95 percentile male rule.
Okay,
Yeah,
sir.
you can find the details on Google if you want. Uh, yeah, in
Sure,
that
sir.
rule, one more thing is specified.
Thank you.
One more thing is specified in that rule. Sitting positions of the driver, how driver is going to sit in a vehicle, and what are the seating angles, what is the back angle is going to be in while designing a roll cage, while specifying the sitting positions of the driver. All these parameters are also included in that rule. So if you want, you can also take a specification from that PDF of that rule book also. Yes.
Mhm. One more point, sir. Has anybody tried out with a foam panel at the front or at the side? What would be the impact?
Not much, sir. The impact will be going to be the same as basically the thing is the governing authorities for which the rule is going to be the rule cage is going to be designed does not allow us to use a foam panel first. And if we did use a foam panel, then it will work as a damper out there. So the force value will definitely be
Yes.
reduced. No second point in that.
Yes.
So it will work as a damper over there. So it will soak up the
Yes,
impact.
sir. Yes. So have you ever tried it with the simulation just for curiosity sake?
No, sir, not yet. We have not used the damper in front impact in simulations, but I think it's a good suggestion. We can try it out, and we can after trying we can analyze the results. What are the results we are going to have? So it's a good suggestion. We can try it out there. Yeah.
Okay, sir. No more questions from my side. Anyone from the audience would like to ask some questions? I think there are no more questions, sir.
Okay. Okay. So
So
this is the
that brings.
yeah. So this is the process of generating a report. Let me conclude it, sir. So it will taking some time. So just one thing, after the report is going to be generated, you can verify and analyze the results that we have included in it, and all the parameters that we have used in the designing of this component or analyzing and simulating of the component. All the parameters are included in that report. So this is the simple and easiest way to include all the values and all the parameters that we have used in a common report. So this is how you generate a report in SolidWorks, and that's all for the session. Yes, sir, you can continue.
Yes, sir. Yeah. So with that, we will conclude this particular session. And on behalf of the Department of Mechanical Engineering, I would like to thank Mr. Ashutosh for taking time of out of his busy schedule and addressing us and educating us on how to go about the analysis for uh, the impact testing of the roll cage in EV.
Yeah.
Thank you very much, sir.
Yeah. Welcome, sir. Welcome. Thank you for this opportunity.
Sure, sir.
Yeah.
So
Okay.
I'll be posting the attendance link now through the chat window. Students are requested not to enter any data into the Google form that will be shared now through the chat window. Participants, kindly access the Google form and provide your feedback, valuable feedback, as well as your attendance for this session. Thank you, one and all. So we'll continue with the faculty development program tomorrow, which will be the last day of the 5-day FDP on sustainable solutions in hybrid vehicles.